With blockchain technology, there are a lot of really cool things that it can do and a lot of really cool ways you can actually interact with the blockchain. Developers are able to access blockchain or smart contracts through other smart contracts, consoles, terminals, and things along those lines. But the most common way to actually interact with a smart contract, and the way that's the easiest for your users, would be create a user interface. In today's video, we're going to be making a basic user interface in which it connects your wallet as well as loops into the smart contracts, so you're able to actually interact with that smart contract through a user interface that we create today. My name's Anthony with the Blockchain Dojo, where we turn you into a blockchain ninja and a Solidity expert. If you learned something new, please like and subscribe, and stay tuned for more content. Let's get started. So to get started today, first thing we're actually going to do is just recap the smart contract that we created. So if you take a look over here, we will go through the SPDX license identifier, declare the Solidity version, declare a contract, and name the contract. We then declare a variable owner, the UINT coffees for number of coffees purchased, as well as the coffee price. We then have a mapping of the coffees that each individual user purchased and how many, an event for the coffee purchased, and then a constructor. The constructor takes in one variable, which is the coffee price. We assign the owner to the message.sender, which is the deployer of the contract, and then set coffee price to the coffee price that we passed into the constructor. Next, we have a buy me a coffee function in which it takes in a number of coffees that you're looking to purchase. It's a public function and it is payable. We have one require check here that takes in that the value of the message being sent is going to be greater than or equal to the number of coffees purchased, declared here, times the coffee price, and the coffee price is what we initialized here in the constructor. From there, we increase the coffees by the number of coffees passed in, and then we change the mapping of user's coffee from the message.sender to add in the number of coffees, and we emit a coffees purchased event. Next, we have a withdrawal function. This is what allows us to withdraw the balance of the contract, requiring that the sender of this withdrawal function is in fact the same address as the owner, otherwise it will revert. And then we have a success call where we send in the value of this balance and require that the transfer was successful. The rest of these are just bonus functions that I went over in the previous video, which as mentioned is linked below. So next, what we're going to do is actually going to create the React front end. So as you can see, I already kind of built this all up and have some basic components and everything put together, but I'll show you the basic steps on how to create a next app. So you want to move into the directory that you're looking to create, documents, YouTube tutorials, boom. Then you want to do mkdir, and we'll do example react, cd example react, and then you want to do npx create React app, and then dot. That creates the React app. After we create the React app, what's next is you're going to initiate hardhat through the npx hardhat init command, which we'll do that in 1 second. Before we actually do init the hardhat command, what we want to do is do rm readme to remove the readme file. That way there's no conflict when you are initiating your hardhat file. So then you do npx hardhat init. Yes. Create a JavaScript project in the root, add a git ignore, add the toolbox. And just like that, you have the project files outlined and put together. We're not going to be starting this over from scratch. What we'll be going over is the front end that I already put together. So what we did here is we have a home component in the app function. For those of you who don't know, the app is then put over here, added to the root. So the React DOM create root, grab document ID, element by root render, and then we render in the strict mode. So what we're going to be going over is the home. So we click over to home. We see a lot of use states. We see a lot of imports, which we'll go over. The first thing we want to go over before all of that is this wallet button. So the wallet button, or at least in this component, what this does is this actually provides the button to connect your MetaMask to the website, as well as every time you load it up, it automatically checks to see if there is that MetaMask. So how we do that is we'll start here first with the connect to wallet. We want to put within a try catch block, we're going to do an if window.ethereum. So what this does is it checks that the browser here has the MetaMask extension. If it does not, we throw an alert, please install MetaMask extension. Next, we grab all the accounts which are connected through the await window.ethereum.request, and when they do the method eth request accounts, and then if the accounts.length is there, meaning that there are accounts found and it is greater than 0, we're going to set the accounts to the first in that account array. Next, we have our connect check if wallet is connected function. Similar, we have the try catch block. We're going to check if there is a window.ethereum, which is just checking to see that we do have MetaMask installed. We're going to grab the accounts, except instead of the request through the method, we're going to do eth accounts instead of eth request accounts. We then also check the length of the accounts array. If there isn't a length, we set a current user to accounts 0. Boom. And then what we do here is we have, if there is a current account in state, or if there is not a current account in state, we create the button, connect to wallet button. If there is, we just pass in the current account, and that is what generates this account number, or your MetaMask account here. And then one other thing that I did with this specific component is I passed in the current account and set a current account state from the parent component. In this parent component, we import use state and use effect, the wallet button component, ethers, then we import in the coffee address, which is the address of our coffee contract, as well as the coffee ABI. What you can do, or what I did specifically for this, was I took the ABI from the contracts, as well as the address, which you can see down here, which is from when we deployed it, and I stored it in this constants folder, which has addresses and coffee.js, which is the ABI, which is then imported into this. We then declare quite a few state variables. So we have current account, coffee contract, coffee price, number of coffees, which is the number of coffees purchased, and then the current balance. What we want to do first is we want to get coffee contract and price. So again, try catch block. If there is window Ethereum, if there is not a window Ethereum, we're just going to return right out of this function. We're going to grab the provider, which is a new Ethers browser provider through the window.ethereum. So we're pulling the provider through MetaMask. And then we're going to grab the signer through the await provider.getSigner method. Next, we're going to pull an instance of the contract, which is new ethers.contract. We're going to take that coffee address that we imported in, the ABI.ABI, so we grab just the ABI, and then the signer, which grabs an instance of this contract, and we're going to set it through the set coffee contract state variable. We're also going to do the same thing for price, which is going to get the price of each individual coffee, and then we're going to set that to string when we set it to the state variable. And same thing with the contract balance, so that we can see the total coffees purchased, total balance of the contract. So price for one coffee, contract balance. Before we get into the buy coffees function, I want to go over the conditionals, the ternary conditionals that we have here. So we have a coffee. If there is no coffee price, we're going to be doing fetch price, and then if there is a price, we put this in here. Current balance, same thing. Ooh, little typo here. And then contract balance, and then if there is no coffee contract, we're going to specify that. Otherwise, we're going to put in this display buy form. So before we get into all that, in order to fetch all the coffee contract price and balance, we're going to use a use effect hook, calling in the contract and coffee, and it's going to be triggered when the current account state variable is set. We do have the display buy button form, which we have just a small little div here, which is just a label number of coffees to purchase, the input, which is the number of coffees that we want to purchase, and then the button. The button has an on click, which is buy coffees func, and we can go over that right now. All right, so for the buy coffees func, I did a try catch block, and with this, I did if the number of coffees is equal to 0, console log cannot buy 0 coffees. This is just a quick check to make sure that this number here is 0. Next, what we want to do is we're going to get the coffee price and then the number of coffees. Then we're going to declare a transaction calling the coffee contract to do buy me a coffee, which is the function provided in order to buy a coffee, and then we pass in the one variable number of coffees, which is the number of coffees were purchased, which is grabbed from this input right here. And then we're going to pass in the value, which is the number of coffees as a big int times the coffee price in int, and that provides the total number of ETH that needs to be sent over for all the coffees looking to be purchased. I can clean this up right here. Next, we have a response, which we're going to await the transaction.wait. And then if the response.status is equal to 1, alert transactions completed, otherwise transaction has failed. So I know we went over a ton of code. I went through a lot of lines on how to actually connect MetaMask to the front end, as well as how to interact with the contracts. But let's actually show you how it all works in real life. So as you see over here, we have everything pulled up. Let me just do one thing here. It's always a good idea to essentially just clear the cache here in your MetaMask. That way there's no nonce issues. Next, we're gonna do coffee's the purchase. We'll do 1. Boom, as you can see here, the gas and then the total ETH being sent, which is 1. We're gonna confirm the transaction. Since we are on the hard hat local node, the transactions are confirmed and mined immediately. We click OK. Boom, and then we see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 zeros, which is, as we all know, equal to 1 Ethereum. That was a quick overview of how to connect the front end to MetaMask and hook into smart contracts. This is a part 2 to the Buy Me a Coffee contract. If you did learn something new, please like and subscribe and stay tuned for more content. Take care, everybody.